So hello everyone, welcome to our PLC course. This week we are going to cover the programming counters, which is CTU and CTD. A counter is going to be in a PLC is a programming instruction used to count discrete events such as pulses, object detections, or machine cycles. It keeps track of how many times a specific condition occurs and performs an action when a set value is reached. So what is CTU? CTU is going to be dedicated to our up counter, and CTD will be dedicated to our down counter function here. So in the first part of our course, we are going to cover the up counter. In the second part, it's going to down counter. And at the end, we are going to put both up counter and down counter together in our RSLogix 500 to see how actually they interact with each other and how they complement each other very well in our PLC logic. Before we start actually doing our programming PLC, we need to first know what are the different bit means for both CTU and CTD. And then here I have summarized these informations from the book of Programmable Logic Controllers, 6th edition. So the count up enable bit is going to be dedicated to our up counter specifically, and then the count down enable bit will be our down counter. And these are basically the two of different enabled bits we are going to utilize mostly in this video. So the count up enable bit is the count up enable bit is used with the count up counter and is true whenever the count up counter instruction is true. If the count up counter instruction is false, the CU bit is going to be false as well. Similar to CU bit, the CD bit is used with the countdown counter and is true whenever the countdown counter instruction is true. If the countdown counter instruction is false, the CD bit is false. And then in both CU and CD bit will be used by our done bit, which is DN bit. You should be familiar with this one from our last course with the timers, on delay timers, off delay timers, and then the retentive timers. Off delay and on delay and off delay timers are non-retentive timers, and if you want to actually hold the accumulated value in the timer, we are going to call these retentive timers, and then this is where we use actually done bit also the last week, if you remember. If you want more information, you can go and watch the previous videos I have uploaded. But in this video, we are going to focus on our programming counters. Anyways, if you're getting back to our done bit, the done bit is true whenever the accumulated value is equal to or greater than the preset value of the counter for either the count up or the count down counter. On the other hand, even though we don't use so much, but we are going to learn how they function, we are going to have overflow bit and underflow bit. As you can imagine, overflow bit will be utilized together with the up counter, and the underflow bit will be utilized together with down counter in our logic. The overflow bit is true whenever the counter counts past its maximum value, which is 32,767. On the next count, the counter will wrap around to negative 32,768. You will see soon in the programming. And then this logic will continue counting towards 0 on successive false to true transitions of the count up counter. I will fix here, there's a mistake here, but if you're checking through the underflow bit, the underflow bit will go through when the counter counts below negative 32,768. The counter will wrap around to 32,767 and continue counting down toward 0 on successive false to true wrong transitions of the count down counter. And then you will see another bit, which is what we call most legacy bit, and then we don't use it much, but update accumulator bit. Update accumulator bit is used only in conjunction with an external HSC, which is high-speed counters. In today's course, we are going to focus on all these different bits we have here in our up counter and then down counter. So let's start programming our first counter, which is up counter here. So let's open our RSLogix first. And after we open our RSLogix, our emulator is right now not open, so we need to activate that one later once we are done with the programming our counters. So we can just minimize this one at the moment. So let's open the RSLogix 500 first. And we can create a MicroLogix 1100 series B is going to be our driver. We choose this one, and then we can start now coding our logic in RSLogix. So the first thing is we are going to add here is our input. Our input will be 0-4. Then we can give a name of this one as switch 1. So this is going to be input, and here is the timer and counter section we are going to utilize. The last week is on, timer off, and retentive timer. We have seen this week we are going to see the count up and count down, and again we are going to see the reset function as well at the end. So let's start with the count up. So our counter will be dedicated in this example is C5 column 0. So this could be our CTU counter. And then our preset value will be 10 in this example. Right now our accumulated value is 0. So let's check the second rung. We get back to our user. We click our examine if closed. So we add this one here. Then we create our first bit, which is connected to our CTU counter here, the CTU block here, which is C50, which is the same address as you can see, C5 column 0 dot. The first one is going to be our CU bit, which is the count up enable bit, CU. Then if you do not enter any name, our CTU counter name will be copy and pasted towards to this child node here. This is the parent node, this is the child node. So to understand what's going on here, we need to create some output energize here. So this is going to be output column 0-0. We can just give a name of green light. You can give whatever the name you want. This is just for example purposes. We go to our second rung. Again, we create another open logic here, C5 column 0 dot. This time we are going to add done bit. Then we just copy paste the name of the parent, CTU counter here, if you don't enter anything, and then we need to have another output energize. This time we are having output column 0-1, and then we can enter yellow light for this example. And in the third rung, we have our overflow bit this time, C5 column 0 dot overflow. Then our output will be O.0-2. Since we put green yellow, we can use the red light. And then this is all we are going to have. in this very basic programming to understand how the CTU counter works along with their CU bit, DN bit, and overflow bit. So if you remember, CU bit is going to be our count up enable bit, DN bit is going to be our done bit, and then overflow bit is going to be here we have. Now let's verify this project and save on our desktop. So this is going to be the CTU new programming. Where did we save? Okay, let's see if we did save correctly. I believe we saved under the documents. Anyways, let's close down this one and then we open our emulator. Can click here. Come back to our documents, CTU new, click open, choose our workstation 1, click OK. Now we can open from the documents our CTU new. And here we go. So what we need to do here is to click the comms who active go online to start running our PLC here. Then when we click OK, as you can see, our RSLogix is activated right now with our programming function here. So we can actually run this program. Then voila. So the rungs are right now energized and it's waiting for our command to continue with the understanding of our CTU counter. So the first part is, let's see if we toggle the bit in switch 1, what's going to happen. As you can see, accumulated value just increased to 1. And then our CU bit become energized after we actually energize our CTU counter here. So the CU bit is energized, our green light is open. If we toggle the bit and close the energy from this counter, CU bit will be not energized anymore, as you can see. Then let's do it again. CU bit is again energized, and then the accumulated value becomes 2. So 1 plus 1, 2. That was the second toggling our bit here. As you can see, the done bit and overflow bit in both status is just not energized. So you can ask, how do we actually energize our done bit? Done bit will be energized whenever the accumulated value is reaching to our preset value here. So we can very quickly toggling our bit until we reach the 10. So toggle. We are almost there. 7, 8, 9, and this 9 will be 10 now, and then our CU bit will be energized, and then we can look at done bit. Yep, done bit is also energized. So our green light and yellow light is open, but you can ask what happened to our overflow bit. It is still not open here. So let's close. CU bit is false, DN bit is true, overflow bit is still false. Then you can ask, why do we have overflow bit, and then what exactly is the function of this one? Let's get back to our PDF file here. Overflow bit is true whenever the counter counts past its maximum value, which is 32,767. And then on the next count, the counter will wrap around to negative 32,768 and will continue towards the 0 on successive false to true transitions of the count up counter. So which means that we need to pass the value of 32,767 to be able to actually energize our overflow bit here. Let's check really quick again. Yes, the file is here. So we can just simply type this one is 32,765. So right now our accumulated value is in 32,765. Then let's see if we reach 767 here. So we energize 66, we close, and then now watch the overflow bit here after a couple of toggles here. So we reach 32,767. As soon as I click this one, this will change to negative 32,768, and our overflow bit will be energized in our CTU counter here. So if we close, our toggle bit is still overflowed, and then you will see this negative 32,768 will be 67 because you add counter up, which is +1. As you can see, 67. So only way to close this overflow bit is going to be adding the reset function, which we are going to see at the end of our video here. But in this one, I'm just going to pass through there. But what you need to do here is to add our reset function in timer counter here. So I hope this makes sense in the counter up section. So we are done with this example. We can just simply, no need to save, no. And then we close, put it on the hold, close. And then we can now open our CTD, which is counter down. Let's see. So we click station 1, both hold, and we click the CTD. So this is exactly the same one, but this time our CTU counter becomes CTD counter, which is counting down. So let's see, comms, who active, go online. We choose our logic and then remote programming. Now we can run our program. And then hola. Then let's start with toggling the bit in our switch 1 to see what the accumulated value will be. So we toggle the bit, -1, okay. We toggle the bit again. So -2. So it keeps adding -1 to our accumulated value. So you can ask then what is going to happen? What is the main function of having this CTD counter instead of CTU counter? Because our CTD counter, the DN bit, needs to reach our actually the preset value to be able to trigger this DN bit here. So by starting with the 0, we are never going to reach the preset value ever. So as you can see, nothing happening. So what we can do here, let's see if we enter 12, and then our DN bit is now active, the energized, because our accumulated value is bigger than the preset value. So toggle bit, our CD bit, this is different than the counter bit, by the way, counter up bit. This is not CU, this is going to be CD bit when you use the countdown here. And then this is DN bit, still the same. Toggle bit 11, it is 10 to 10, we are equal. As soon as we reach the 9, in the next toggling the bit, you will see this DN bit will be de-energized. So our CD bit is now energized. We toggle the bit, we close it. Let's energize again. And then DN bit is gone. Then our CD bit is here, true. But as soon as we close the switch, this counter block is false. Our CD bit is going to be also false. And our accumulated value is 9. So this is how exactly works the CTD counter comparing to our CTU counter. And then we also have underflow bit. Let's see what exactly we can do. Negative 32,767. Then actually we can check here. So this is 32,768, the negative. So this is 767. Let's toggle the bit. Now we are on the limit. Toggle the bit, and then as soon as we toggle the bit, our underflow bit is now active. And then you can see this negative 32,768 changes to the 32,767. And then once we toggle the bit, CD is gone, DN bit is not going to be active, and then our underflow bit is energized here. And then as long as you don't have any reset function, this will stay here like this at the moment. So this is how the CTD counter works. Now what we can do is close this one and then show the next example. So let's put this on hold, close, and then we can open our CTU and CTD example here. So this example is taken from the book of Programmable Logic Controllers 6th edition from the 2022 release. So what we can do here is you can check the figure 8.22, which is up-down counter programming. This is where it came from. So our input A is going to be the input of our counter up, as you can see, CTU here. On the other hand, our input B will be the input of CTD, which is count down bit. And then the addresses of this input A will be I column 0-0, input B will be 0-1. This is 0-0, 0-1. And then at the end, we also have reset function here, which is coming from our timer counter section, exactly as you can see. And then our input is going to be 0-2, 0-2, 0-1, and 0-0. Input A, input B, and input C. In addition to our inputs, we also have our CU bit, DN bit, and CD bit, and DN bit. This is CU bit, CD bit, and DN bit. In this example, we don't have any overflow bit or underflow bit, so you can ignore those parts at the moment. We only have CU, CD, and DN bits, which all are connected to our address, which is C5 column 2. C5 column 2. Let's click here, our data table. So in the previous examples, we used the address is C5 column 0, but in the specific example taken from the book is using the address of C5 column 2. So do not get confused what is 0, what is 2. There you can just change this 2 to 0 for both, and then you will be fine. But in this example, we just use C5 column 2, and then you can see the preset value in here is 10, 10, 10. Our accumulated value is right now 0. So let's check what's going to happen if we go online. We click this one, and then we click the running our program. Yep. Now we energize the entire PLC logic we have here. Let's start with the up counter. So toggle the bit, CU counter is up, energized, and then both accumulated value is 1. Let's toggle the bit really quick. 2, 3, 4, we are going to have the same thing with the counter up. Just CU bit is keep getting energized and de-energized until accumulated value reaches our preset value, which is 10 in this example. Then you can see how the CTU and CTD work together perfectly in this example, and then how they actually complement each other very well. So, yep, you see that the accumulated values reaches the preset value is 10, done bit is activated, and CU bit is activated, and then we just close the input A, the CTU block is false, but since accumulate value reaches the preset value 10, our DN bit is right now active. But if you energize our counting down block, our accumulated value will be added with the -1, which means that 10 -1 is going to give you 9, and then done bit is going to be de-energized. But the CD bit is online right because we are true on the CTD block here. So as we can close, the done bit is gone. Let's activate the toggle bit again. Done bit is activated. Then we close the done bit is gonna stay here whenever until we come back under the preset value 10, but our accumulated value is 12 at the moment. So what we can do here, instead of using the countdown block to go back under the 10 or going back to the initial value 0, we can use our reset function here. So we click this one, we toggle the bit, reset. As you can see, accumulated value is now 0. We can just close this one and then hold on. Everything is just go back to the initial position. So how you can use the CTU and CTD here is you can count the parts on the conveyor like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then whenever you face with defective part, you can count down by using this CTD block here. So this is how you utilize this count up and count down counters in this example here. This is a very simple example. You can add multiple counter up, counter down together to create a more complex example, but this is how the CTU and CTD interacts with each other by using the CU, CD, and done bit. And if you want to go back to the initial position, you just simply add the reset function here in this timer counter section in the RSLogix 500. So this is all we have for this video. So let me know if you have any questions. Other than that, thank you for watching.